Hello students. Uh, so this is the lecture. This is the lecture 4, and today we are going to discuss about the PCB manufacturing. So this is a overview of PCB manufacturing. So you can see that in this PCB manufacturing, it will first start with design. Design means through some softwares, we first have to decide the circuit. So in the design the circuit, there are different types of softwares available in the market. One of the very popular software, it is called Easy EDA. So in this Easy EDA, through the Easy EDA, we can able to design the circuit, and we need to simulate the circuit. Simulation. We can do the simulation of the circuit. After that, when they during this simulation, so virtual PCB board we can able to design. In the back side of the board, some pattern will be designed through the software. After that, this pattern will be need to print. So how you this in this printing method, the pattern what we design, any wire pattern, anything. So this thing will be print. After that, we need to prepare the copper, because in the back side of the PCB board, in the back side of the PCB board, the what the pattern we have printed, this pattern we have to print through the coppers, so the metal, because the backside is nothing but a metal contact is there. So we need to give the copper in the backside. After that, I etch out. Etch out means suppose some pattern is there. After that, I give some copper on it. After that, when I etch out, as per the pattern, what I have already designed through the simulation, my copper will be printed. My pattern will be printed, and the copper metal will deposited on in this on in this design. That means in this pattern. Understand? So first we have to design the pattern. This pattern I have to print it into the film. After that, we deposit the copper. After that, etch out this copper. So where the pattern is not there in this board, so in that area the copper will be etched out, and the copper will be deposited when this pattern is there into the board. So for this reason, so as per our any pattern, I think as per our pattern, like that, any pattern, it will be deposited. After that, we need to drill holes, because in the backside, the patterns are there. After that, we need to deposit the component. In this component, when I go to deposit this particular component, suppose if I want to uh, mount one resistor. So in the resistor, we need two holes. To suppose this is a PCB board, two holes there, and suppose this is the resistor. If I want to mount this resistor inside the board, I need holes. So these holes we have to make into this PCB board. So like that, PCB manufacturing we need to do. Okay. So first in the simulation part, uh, we need to schematic capture. That means what schematic we need to fabricate this schematic. I need to capture first through some EDA tools, electronic design automation tools, software. I already told one software. It is called Easy EDA, and it is open source software. So we can able to do the capture the schematic. After that, PCB layout. We have to where the copper traces is needed, and where my components I need to mount this PCB layout, I need to fabricate or need to decide. After that, DRC check, design rule check, ensure the manufacturability of this PCB board. So next step, printing the circuit design from digital to physical. So the finalized PCB design is exported as Gerber files, the industry standard format for fabrication. So Gerber file is one type of file. When you're doing the simulation through any software, the software will provide this type of file, and this file is a industry standard. So this file will generate. This files will be helped to use to generate a photographic film for each copper layer. The film acts as a precise blueprint, masking areas where copper should be preserved and exposing areas to be etched away during the subsequent steps. So this file will be tell you where the copper is needed and where this copper is not needed. So this type of file, what will be generated using our uh, design software, this file is called Gerber files. So next is copper clad board and drilling. So base substrate is, all of you knew that it is a PCB FR4 substrate. After that, a thin copper foil is bonded to one or both sides of the substrate using heat and pressure, forming the conductive layer. After that, what will happen? High-speed CNC drill machines create holes for through hole component and tiny channels that connect copper layers electrically. So that means simple thing what I am saying. Uh, what I'm saying, simple. Uh, this PCB board, where this suppose this type of connections, electrical connections are there. So I need to one components if I want to mount, suppose. So suppose these two holes I have to create. In this hole, I this through this hole I can mount the component. So this all pattern is called the copper lamination, where the copper is there. CNC drilling means the drill of these holes and hole plating. And drilled holes are plated with copper via electrode deposit, enabling electrical continuity between board layer. That means these drill holes you have to for the electrical continuity you have to plate it with copper. Otherwise, the continuity will be not there in these holes. After through these holes, we have to drill or drill the holes first. After that, we need to solder. Next, the photoresist application. PCB manufacturing step of the first critical step in PC fabrication, a light sensitive chemical coating is applied uniformly across the copper. What I told you, uh, copper clad board surface. This photoresist layer acts as a blueprint medium. When exposed to UV light through a photo mask, it hardens in the desired circuit pattern, protecting the copper bench while excess material is washed away. So there are two types of resist. There is positive resist and negative resist. Positive resist means exposed area becomes soluble and wash away, and negative resist means exposed area harden. It will not be removed. So actually, simple thing. I have to give the copper. After that, we use the photoresist. Where I need to uh, deposit the copper in that area, I have to give negative resist. When I not want to copper, I have to give positive resist. After that, when the chemical solution, when I going to etch out or UV exposure light, sometimes we use this photo light transfer the circuit pattern from the photo marks to board. Understand? So suppose one area where I want the copper, in that time this area I have to deposit negative resist. Where I am not want copper, I have to deposit for positive photoresist. These two materials are there. So after that, when a UV exposure is there, precision UV light transfers the circuit pattern. That means where the copper is there, the pattern what I want to decide to print, this particular pattern, the copper will deposit, and we can able to find the circuit like that. So the etching process is very important process. With the photoresist pattern in place, unwanted copper is chemically dissolved, leaving only the precision circuit traces defined by the design. This step transfers a blank copper clad board into a functional network conductor. So chemical etching is there. Ferric chloride or ammonium sulfate solution dissolve exposed copper with high precision. Temperature and concentrations are tightly controlled to ensure clean, sharp trace edge. So when etching will be happen, what I told you, uh, where I want to deposit the copper, here we have to positive photoresist will be there, and where you not want to copper, negative resist will be there. So due to this, when I give the solution, a chemical solution, etching solution, so in this part where the copper is not needed, it will be etch out, and where copper is needed, it will be deposit. So we can able to find this type of pattern, this type of backside pattern, bottom pattern, we can able to find out. So the solder mask application, protection insulation, a polymer layer, most commonly green epoxy, is applied over the etched copper traces. The solder mask prevents accidental bridging between pads during the soldering, protects against oxidation, and insulates conductive path from environmental exposure. So this is the solder mask what are we going to use during the when we are going to deposit the copper where holes are there. At last, we need to test. There are different types of testings are there. One is AY inspection. High resolution cameras can portray the defects, where the defect is there during is there or not during the soldering, during this drilling, during the etching, anything is there or not. This thing uh, should be uh, find out through high resolution cameras, scan for trace defects, so many things will be after the electrical tracing. That means keep some electrical current. After that, we have to find out the connectivity is there or not through multimeter, through some other measurement instrument, the conductivity, all are the equal connectivity is there or not, we can have to do. After that, component mounting, SMTP can place machines and TST insertion precision populated the board, and mounting is okay or not, this thing also be we have to take care. Okay, so in the next video I will discuss about the other analysis part and design part of the PCB. So thank you for joining. Again, I am going to thank my students uh, to help me much uh, to prepare this video and presentation. Thank you.